Welcome to the lecture series on orthogonal trajectories. Today let us solve few problems on orthogonal trajectories, and this first problem I am going to do is finding orthogonal trajectories of the family of parabolas y square is equal to 4ax. Now let us try to find the orthogonal trajectories of this. First I will write the given equation y square is equal to 4ax. Now I'll differentiate this with respect to x. Now I'll get it as 2y y1 is equal to 4a, where y1 is equal to dy by dx. Now I'm going to substitute this into given equation. So implies the given equation will become y square is equal to, instead of 4a, I'll write it as 2y y1 into x. Now when y1 get cancelled, it implies y is equal to 2y1x. Now this is a differential equation of y with respect to x. Now our step is to replace dy by dx or y1 by minus 1 by y1 to get the orthogonal trajectories. So what I'll do, y is equal to 2 into minus 1 by y1 into x. So this y1 I am going to send this side. y1 into y is equal to minus 2x. Now I am going to replace y1 as dy by dx into y is equal to minus 2x. Now I am going to separate variables so that we can integrate and get the required orthogonal trajectories. So left hand side y dy is equal to minus 2x dx. Now I will integrate on both sides. Integral y dy is equal to minus 2 into integral x dx. So I'll get y square by 2 is equal to minus 2 into x square by 2 plus c1. So if I multiply 2 on both sides so that we can remove the denominator, so y square is equal to minus 2x square plus c, where c is the integrating constant. I can write c is equal to 2c1. So therefore the required orthogonal trajectory is y square plus 2x square is equal to c. Thank you.